Find the Riemann sum for the curve y equals x squared plus 1 over the interval 0 to 1 using 5 rectangles and using left endpoints as the sample points. Okay, so we're going to take the interval from 0 to 1 and we're going to break it into 5 equal pieces, and the width of each piece will be delta x, and the formula for delta x is b minus a, which is the width of the entire interval, divided by the number of pieces. So in this case, 1/5. So these partition points here are 1/5, 2/5. You just start with the first one and you keep adding delta x. So 0, 0 plus 1/5, 1/5 plus 1/5, etc. So 3/5, 4/5, and then 5/5, which is 1. So we have these 5 subintervals from 0 to 1/5, from 1/5 to 2/5, etc. until we get to the last one, which is 4/5 to 1. Then the sample points will be the left endpoints of these intervals. So the sample points will be 0, 1/5. The next interval is from 2/5 to 3/5. So the sample point will be the left endpoint 2/5. And there's an obvious pattern here. The next one, the interval is from 3/5 to 4/5. The left endpoint is 3/5. And the last one, the left endpoint, is 4/5. So the Riemann sum is given by the summation. I goes from 1 to n of f of xi star times delta x. And in our case, n is 5. So this is f of x1 star times delta x plus f of x2 star times delta x, etc. up to f of x5 star times delta x, where x1 star is the first sample point, which is 0. So this is f of 0 times delta x. F of x2 star is the second sample point, so f of 1/5 times delta x. And let's write them all. F of 2/5 times delta x, f of 3/5 times delta x, and the last one is f of 4/5 times delta x. And we can factor delta x out of this. The Riemann sum will just calculate the values of the function and multiply them by delta x. So delta x times. And now f of 0, we have to break out our function here. So f of x is x squared plus 1. F of 0 is 0 squared plus 1, which is 1. Then f of 1/5, f of 1/5 is 1/5 squared. 1/5 squared is 1/5 times 1/5, and multiplication is done straight across. 1 times 1 divided by 5 times 5. So 1 over 25, and then plus 1. And then f of 2/5, 2/5 squared is going to be 4 over 25 plus 1. So let's see, f of 1/5 was 1 over 25 plus 1. F of 2/5 is 4 over 25 plus 1. F of 3/5 is going to be 9 over 25 plus 1. And f of 4/5 is going to be 16 over 25 plus 1. And the delta x is 1/5. So what do we have in the parentheses? 1, 2, 3, 4, 5 plus 1s make 5. And then how many 25ths do we have? 1 and 9 make 10, and 4 and 16 make 20. 10 and 20 make 30. So we have 30 25ths. And then we can simplify that. This is divide top and bottom both by 5, and it's 6/5. So 5 plus 6/5. And that's our Riemann sum. We can do a little more arithmetic here. Let's distribute the 1/5. 1/5 times 5 is 1, and 1/5 times 6/5 is 6/25. And if we want to leave the answer as an improper fraction, 1 is 25 25ths, and so this is 31 25ths. So that's the value of our Riemann sum. Let's just take a look at what that means from a graphical standpoint. We have the curve y equals x squared, and x goes from 0 to 1, and what we did was we put, whoops, that's not quite right. It wasn't y equals x squared. It was y equals x squared plus 1. So we had this parabola here, and x goes from 0 to 1, and we broke this interval into 5 equal pieces, and we made 5 rectangles using the left endpoints. So our Riemann sum is the area of these 5 rectangles. And the areas where, well, we don't have the numbers for each rectangle. They would be 1 times 1/5, etc. 1/5 times 1 plus a 25th. These were the heights in the parentheses here. Those were the heights, and the widths were all 1/5. So this is the an approximation to the area under the curve y equals x squared plus 1. And the total value was 31/25.